Hello friends, welcome to our Grade 8 Mathematics Student Support Program. Our topic for today is surface area and volume. We are going to look at the last part of this chapter. So after watching the first two videos on this chapter, you should be able to understand how a net of a cube and a cuboid is obtained. You must also be able to recognize that the total surface area of a cube and a cuboid is the sum of the areas of all the faces of the nets. You have also learned how to develop and apply formulae to calculate surface area of a cube and a cuboid, as well as develop and apply formulae to determine the volume of a cube and a cuboid. You have also solved problems involving surface area and volume of cubes and cuboids. So in this video, you will learn how to fit cubes or cuboids into other cubes or cuboids. So let us start. First example. A cube of edge 3 cm is fitted into another cube of edge 15 cm. How many 3 cm cubes fit exactly into the big cube? So let us have a look at the solution. I have a cube of edge 15 cm and I'm going to fit in smaller cubes of edge 3 cm into the big one. So along the length, I'm going to have how many cubes of edge 3 cm? So it's going to be 15 divided by 3. So I'm going to have 5 3 cm cubes. In the same way, along the width, I'm going to have 5 3 cm cubes. Similarly, along the height, I'm going to have 5 3 cm cubes. So in all, I will have 5 times 5 times 5. That is 125 3 cm cubes will be needed to completely fill in this cube of edge 15 centimeters. A second example. Now, a cube of edge 5 centimeters is fitted into the cuboid below. So my cuboid has dimensions 25 centimeters, 20 centimeters, and 15 centimeters. What is the largest number of 5 centimeter cubes needed to fill in the cuboid? Let us have a look at the solution. So I have 5 centimeter cubes which will be fitted in the cuboid with dimensions 25 centimeters, 20 centimeters, and 15 centimeters. So how many cubes will I need? How many 5 centimeter cubes will I need along the length? So here's the length, 25 centimeters, and I'm going to fit in 5 centimeter cubes. These smaller cubes will fit in the bigger one. So here I'm going to have 25 divided by 5. So I will need 5 cubes along the length. Now, along the width, which is 20 centimeters, it's going to be 20 divided by 5. That is, I will need 4 cubes along the width. Along the height, which is 15 centimeters, I will need 15 divided by 5. So 3 cubes will be needed along the height. In all, I will need 5 times 4 times 3, that is 65 centimeter cubes to completely fill in the cuboid. A third example. Cubes of edge 3 centimeters are placed in a box of dimensions 18 centimeters, 12 centimeters, and 10 centimeters. Calculate, first part, the largest number of cubes that can be placed in the box. Second part, the volume of space left unoccupied. So the dimensions are 18 centimeters, 12 centimeters, 10 centimeters. And I'm going to place cubes of edge 3 centimeters. So just like we did before, we are going to see how many 3 centimeter cubes can fit along the length. So 18 over 3, which is 6. In other words, 6 cubes will fit exactly along the length. Along the width, I'm going to have 12 divided by 3, that is 4. So 4 cubes will fit exactly along the width. Now, along the height, I have 10 divided by 3, which gives me 3 1/3 cubes. So exactly 3 cubes will fit along the height, and there will be a remainder of 1 centimeter. So the largest number of 3 centimeter cubes that can be placed in the box will be 6 times 4 times 3, that is 72. We are going to have 72 3 centimeter cubes in this cuboid. Now, second part, I need to find the volume of space unoccupied. If you remember, we had dimensions 18, 12, and 10. So, in the previous slide, we saw that 1 centimeter will be left. So, the volume of space unoccupied will be 18 times 12 times 1. That is 216 centimeter cube will be left unoccupied. Or I could also have calculated the volume of a cuboid, that is 18 times 12 times 10, minus, we had 72 cubes which fitted the cuboid of edge 3 centimeters. So I can also have the volume of the cuboid minus 72 times volume of each cube, that is 3 times 3 times 3, which gives me 216 centimeter cube. You now have some exercises for you to practice on how to fit cubes into cubes or cuboids. The first question, how many 2 centimeter cubes are needed to make a cube of edge 20 centimeters? The second question, how many cubes of edge 4 centimeters are needed to make a cuboid of dimensions 60 centimeters, 40 centimeters, and 12 centimeters? Question 3. A rectangular piece of iron of dimensions 3 meters by 2 meters by 1.5 meters is melted to form cubes of length 20 centimeters. How many cubes will be obtained? You need to be careful with this question because we have different units. We have centimeters and meters. Question 4. A cube of edge 6 centimeters is put inside a cubical box of edge 8 centimeters. Calculate the largest number of 6 centimeter cubes that can fit the 8 centimeter cube and find the volume of space left unoccupied. Question 5. Cuboids 5 centimeters by 4 centimeters by 3 centimeters are placed in a box of width 16 centimeters, length 25 centimeters, and height 17 centimeters. Part A. Find the largest number of cuboids that can be placed in the box. Part B. Calculate the volume left unoccupied. The last question. The cube and the cuboids have the same volume. The total surface area of the cube is 600 centimeters square. Calculate part A, the length of the cube, part B, the volume of the cube, and part C, the height of the cuboid. You also have some links where you can get some additional practice on fitting cubes into cubes or cuboids, as well as on volumes of cubes and cuboids. So friends, we have reached the end of this video, where you have learned how to fit cubes into other cubes or cuboids. We have also reached the end of this chapter, surface area and volume. So until we meet again, it's goodbye.